Hi, I'm Joshan Abraham, Product Marketing Engineer at Cypress Semiconductor. In this video, I'm going to walk you through EZ-Click 2.0, a software tool for configuring CapSense MBR devices. I will use the CY3280 MBR3 kit to showcase EasyClick. I will start off by opening up EasyClick. First, I'd like to point out the Help menu and the user guide that you can reference for details on every feature of EasyClick. I'll start this by creating a new project by clicking File and then New Project. Here I can name the project, choose a file destination, and select the target device. I can either directly select the device from the drop-down menu or use the device selector to help choose the right device based on my requirements. In this case, I will choose a device that can enable at least 4 buttons and 4 LEDs and has water tolerance capabilities. The tool also has links to the device datasheet and design guide. In this example, I will choose the CY8CMBR 3116LQXI device. Now that I've created a new project, 4 new tabs open up: the CapSense Sensor Configuration tab, the Global Configuration tab, the CapSense Output tab, and the Systems Diagnostics tab. The CapSense Sensor Configuration tab lets me define the configuration settings of the CapSense sensors. Let's say I want to have one proximity sensor. To enable a proximity sensor, I simply select the number 1 in the proximity sensor dropdown. I will also enable 4 buttons: CS3, CS4, CS5, and CS6. Now I can rename the proximity sensor and each button the way I want. I will rename them as Prox, Up, Down, Left, and Right. I can change different parameters like sensor thresholds, the scan period, and filter settings. Details on these features are available in the user guide. The next tab is called the Global Configuration tab. This tab lets me configure some of the global properties of the system, including LEDs, general purpose output, or GPOs, buzzer, and so on. I will enable GPOs 3, 4, 5, 6, and 0 corresponding to the buttons and proximity sensor I already enabled in the previous tab. Please note that these LED outputs are mapped one-to-one with the CapSense sensors. The exact mapping is documented in the MBR3 device datasheet. I will enable the toggle feature on 2 of the button LEDs. Now, I can generate a configuration file by clicking on the Generate Configuration File button in the toolbar. A header file and a hex file are generated, which can be exported to configure the MBR device through a host processor or a third-party programmer. In this example, I'll directly configure the MBR3 device through EasyClick. I'll plug the kit in and verify that the correct target device, I2C speed, slave address, and power supply are selected. Then, I simply hit the Apply Configuration button and the MBR device will be configured. As you can see, I've enabled a proximity sensor and 4 CapSense buttons, with 2 of the LEDs having the toggle feature enabled. Please reference the user guide for more details on the features that can be configured using the Global Configuration tab. The CapSense Output tab allows me to easily see the output of the buttons I configured. There are 2 views possible: the button output view, where I can view the output of a specific sensor. For now, I'll choose the sensor I named as Left and choose the raw count versus baseline graph. Then I hit Start. As you can see, the graph is plotting the baseline and the raw count of that sensor. When I touch the button I marked Left, the raw count jumps up. The other view is a parameter view, which lets me see all the sensors at the same time. I can see the difference count for all the sensors when I touch them. The large spike is for the proximity sensor. The System Diagnostics tab allows you to test the system for functionality during production. The way you do this is by establishing a baseline for faults with the prototype mode. For now, I'll assume that the current board is the prototype. When I hit Start, each sensor is diagnosed for faults like a button shorted to a ground or a parasitic capacitance or CP that is out of range. The sensor's signal-to-noise ratio or SNR and CP are measured. After prototype baseline is established, I can move to the production mode and can test the sensors on multiple boards. EasyClick generates the following graphs for all the boards that are tested: a CP graph, an SNR graph, and a fault condition graph. More details on using the System Diagnostics tab are available in the user guide. This was a brief overview of the EasyClick tool. Please reference our website at www.cypress.com/EasyClick for more details and examples on EasyClick.